Hello all, welcome back to our lab series on GCP Compute Engine. In this lab, we'll focus on intermediate level GCP Compute Engine concepts like creating custom VM images, using snapshots, working with instance templates, managed instance groups, configuring network settings, auto scaling, load balancing, and load testings. We'll be setting up auto scalable sentiment analysis web service using FastAPI to classify IMDb reviews. Let us start the lab now. In the first step, we'll be creating a VM instance, which will be used as an environment to deploy our web service, which will be classifying IMDb reviews. Let us get going. We'll go to the console and we'll be creating a VM instance in the region US Central 1 and zone US Central 1A. And the mission type would be an E2 micro with Debian GNU Linux operating system and a disk size of 10 GB. We'll be creating a VM. Let us name the VM as IMDb Sentiment Analysis VM. And we'll be using the mission type E2 micro. And the image is Debian GNU Linux. And of the disk size 10 GB. We'll create the VM now. While the mission is being created, let us look into the next step. We'll be setting up the environment by installing Python and other necessary packages using the setup script. Let us copy the setup script. We can see that our VM has been created. We use web shell to log in into the virtual machine. Create the setup script. So basically what this script is doing is that it is updating the existing packages on the machine. It is installing new packages like Python, virtual environment, and Git. We are using Git to clone into our project repository. And we are setting up the virtual environment to install Python requirements. And finally, we are installing the Python requirements required for our project. So we've saved the script when we execute it. Let us wait a minute for the packages to be installed. Now all our dependencies have been installed. We can see the Python dependencies required for the projects have been installed. Let us go to the next step. In the next step, we'll be creating a snapshot of our virtual machine. Snapshot allow us to back up the state of our virtual machine, which enables us to quickly recover in case of failures. They also help maintain business continuity and minimizing downtime. So we'll be simulating a failure by deleting our virtual machine. Before that, we'll be creating a snapshot and we'll show how to recover in case of failure by reinstating the snapshot into a virtual machine. So we'll create a snapshot in this name. Before that, we stop the instance. This ensure that the snapshot created doesn't have any integrity issues. We'll click on create snapshot and we'll be naming the snapshot as IMDb sentiment analysis VM snapshot. And the source type is set to disk and the source disk is IMDb sentiment analysis VM. And we click on create. We can see that our snapshot is ready for use. We'll be now deleting our virtual machine. And in the meantime, let us create a virtual machine from our snapshot. We are creating a virtual machine from our snapshot. Let us name the virtual machine as IMDb sentiment analysis VM restored. And basically we give the same configuration that our earlier virtual machine had. For instance, size would be E2 micro. We can see that the boot disk is set to the snapshot now, and we hit create. We'll also validate that the state of the virtual machine we heard earlier and which got deleted is the same now when we restored it from a snapshot. Now our virtual machine has been restored. Let us access the machine with web shell. We can check the home directory. We can see that the machine has been restored to its original state. Let us validate if we have the Python environment set up in our project directory. I'm directly navigating to the lab2 project folder. We can see that we have the environment folder with all the necessary Python packages installed and all other files that are required. So our machine has been restored to its state when it was deleted and the snapshot was taken. With this, we move to the next step. In the next step, we'll be creating a custom VM image. This custom VM image can be used to create new VM instances with the same setup. This helps us ensure consistency across multiple instances. And for auto scaling, when we create a custom VM image, it will have the uh, when new instances are created from a custom image, they'll have the same configuration, software, and environment as the original image, so that we can maintain uniformity across our deployments. We'll be naming the custom VM image as IMDb sentiment analysis image. We'll stop the VM instance to avoid any integrity issues. And let us go to the images. We create an image with the name. The source disk is set to IMDb sentiment analysis VM restored, and we click create, but we'll wait till the VM instance is stopped. Now the VM instance has stopped. We'll create the image now. We can see that our custom VM image has been created, and it is of the size 1.49 GB. Now, as a next step, we'll be configuring network and security settings. We'll be creating a virtual private cloud and subnets and firewall rules, which would allow us to allow traffic from the internet to flow into our VM instance, such that we'll be able to serve our web service with the IMDb sentiment analysis model. So we'll be creating a VPC in the name, IMDb sentiment analysis VPC, and we'll be creating a subnet, so that we'll be able to segment our network into smaller parts. And the subnet would be created on the name IMDb sentiment analysis VPC subnet in the region US Central 1, and the IP address range is 10.10.10.0/24. We'll be navigating to the VPC network section. We'll create a new VPC. We'll name the VPC as IMDb sentiment analysis VPC, and we'll be creating a new subnet with the name IMDb sentiment analysis VPC subnet. The IP address range would be 10.0.0.0/24. The region would be US Central 1. And we click create. Let us look into the next step. As a next step, we'll be creating firewall rules for our VPC in the name IMDb sentiment analysis VPC allow custom, which would allow ingest traffic from the internet, which is 0.0.0.0/0 to specific ports such as 22 for SSH, 80 for HTTP, and 8000 for our FastAPI. Only when we add this firewall rule, we'll be able to receive traffic on our FastAPI service. So we'll be creating a new firewall rule and we'll be naming it as IMDb sentiment analysis VPC allow custom, and we'll be selecting our VPC in the network, and the direction of the traffic is ingress, and action on match would be set to allow. We'll set the targets to all instances in our network so that when we create more instances in the network, they are also covered under this firewall rule. And the source IPv4 range is to be set as 0.0.0.0/0, which means that any IP can send request from the internet. And we'll be allowing only specified protocols and ports in TCP, which would be 22, 80, and 8000, and we hit create. Let us look into the next steps. In the next step, we'll be creating an instance template and managed instance group eventually. An instance template will allow us to define a configuration for VM instances that can be reused. A managed instance group uses these VM instance templates to automatically create and manage group of identical instances, providing scalability and availability. This would help us in managing large-scale deployments. So let us create an instance template. We will navigate to the compute engine. We have the instance template section under virtual machines. We'll create a new instance template and we'll be naming the instance template as IMDb sentiment analysis template. And we'll be setting the machine type to E2 micro. And we'll be changing the boot disk to use our custom image, IMDb sentiment analysis image, in which we have all the uh, packages pre-installed and the environment set up for our IMDb sentiment analysis service. And we'll click select. We'll also configure the network for our instance template. We first delete the default network and we add a network interface with our IMDb sentiment analysis VPC and our subnet set to IMDb sentiment analysis VPC subnet. And one other step we'll do is Under management, we have something called as a startup script. This script is executed on the mission start. So we'll be copying this script. What this script does is that once the mission is booted, it will navigate into our project home. It will activate our virtual environment, which has all the Python requirements installed, and it runs our FastAPI service. So this mission will be able to serve the FastAPI service automatically rather than us initiating this. We'll copy paste the startup script and we hit create. We can see that our instance template has been created. In the next step, we'll be creating the managed instance group. We'll be using the name IMDb MIG and the zone US Central 1C and the instance template we just created. We'll also set the auto scaling policy. We'll look into the auto scaling policy now. We go into instance groups and we create an instance group. We name it as IMDb MIG and we select our instance template. We set the region to be US Central 1 and the zone to be US Central 1C. This is the auto scaling step here, where we configure the minimum number of instances to be 1 and the maximum number of instances to be 3. What this means is that initially, when we create the managed instance group, the minimum number of instances that we configure are created, that many virtual machines are created. And when the overall CPU utilization is more than 60% on these virtual machines, they are gradually auto scaled to add more number of virtual machines to handle the load until the maximum number of instances that we have configured, which is 3. And once the load is below 60%, they are gradually brought down. So we configure the maximum instances to be 3. We'll also increase the initialization period to 120 seconds to ensure that our we give enough time for our startup script to create the model and deploy the service. Let us see. Yeah, that would be all. And we click on create. Now a managed instance group is getting created. We can see that our managed instance group has been created in IMDb MIG. And we can see that external IP for the managed instance group has been provided. Let us copy that and verify if our FastAPI service is up. We'll be using Postman. Let us create a new Postman request. First, let us check. We have 2 routes on our FastAPI service. One of it is the health. Let us hit the health endpoint. We can see that The fast API service is up and status is being provided as okay. Let us also verify if our service is working properly as intended. We'll be making a post call to the predict endpoint. The predict endpoint takes the review param from the request, holding any review for a movie. Let's say that I say the movie was awesome, and we send the request. We can see that our model has classified the review as positive sentiment. This shows that our model is up and the service is running. Let us get back to the console. We can also see that the number of instances on our managed instance group is set to 1, which is the minimum. And we can go into monitoring. We can see that there isn't any significant load as of now because we have just created the instance group, but we have not simulated any load to it. So let us get to our next steps. In the next step, we'll be configuring a load balancer for our managed instance group. This load balancer would help us distribute the incoming traffics across multiple instances, ensuring that we have high availability and reliability. And it'll also we can also configure it to send request only to the healthy instances and not those that have any errors or exceptions or any issues with them. So let us get to creating the load balancer. We'll be creating a new load balancer. This load balancer would be an application load balancer since we have a web service. This would be public facing since we get requests from the internet, and we'll be choosing uh, the global workloads, and we set the classic application load balancer, and we configure it now. When we configure the load balancer, we'll have two configurations. One is the front end and the other is the back end. Front end is basically uh, the part of the load balancer that would take the requests that are flowing in from the users. So we'll name the front end as IMDb front end, which would be operating on the protocol HTTP and on the port 80. And for the backend, we'll be creating a backend. Backend is nothing but the part of the load balancer. Once we receive a request to the front end, the request must be forwarded to instance group, which would be our backend. We'll click on new, create a new backend service, and we'll name the backend as IMDb backend service. The backend type would be set to instance group, and we select our instance group that we have up and running, IMDb MIG, and we'll be using the port number 8000 on which our fast API service is running. One important thing we also do here is that we create an health check. With the name IMDb health check on the port protocol HTTP and the port 8000, and the request path set to health, and we click on save. And in the backend we have already configured the required settings, and we click create. We also disable our cloud armor settings. We are doing this because we are going to simulate a large load from one particular IP address, which is would be my local instance, so that this particular IP address would not be blocked. But in the actual deployment, production deployment, this can be configured as required. We'll click create and OK, and we review and finalize our load balancer configuration. So the front end would be to HTTP port 80, and the backend would be to HTTP port on 8000, and the IMDb health check is used here. We hit create. Before that, we give a name to our load balancer. We can use the name IMDb LB and create it. Our load balancer is getting created now. We can see that our load balancer has been created. Let us open it. We can see the front end. We have the public facing IP address. Let us copy it, which we'll be using later to validate the load balancer. And we can also see that the backend, which is our managed instance group of one instance, is healthy. The health check has validated that the instance is up and running. We'll be making a request to the public address of our load balancer, see if everything is working fine. Let us go back to Postman. We'll be creating a new request, and let us copy and paste the IP address, and first let us make an health check. We can see that the instance is up and running and is healthy. One important thing to note is that once you create the load balancer and you hit the IP address, for some time you might not receive any response, or it might be a timeout. Give it some time of, let's say, 5 minutes to get the load balancer up and running, and once you request it, it should be up and running. Let's also make a request to the predict endpoint with post, and the body, as we did earlier, set to JSON, and with view v2 the movie was boring, and we get the sentiment negative. That's right. So let us get to the next steps. This shows that our load balancer is up and distributing task traffic to our VM instances. In the next step, we'll be auto scaling and load testing. As we configured our managed instance group to perform auto scaling, it would automatically adjust the number of instances in the group based on the load and the CPU. We have already validated our load balancer by making a request through Postman. So let us do the load testing with locust. For that, we'll open Visual Studio Code where we have the code. I have the load test script written here. So basically this script uses the locust package to hit the predict endpoint with this particular review. We'll see how we can configure this. We'll be using the locust -f and the file name load test. Before that, let us get into the directory. Let us see if locust is installed on our machine. So locust is not installed. So I have a virtual environment where locust is installed. Let us activate that and check if locust is installed on my machine. Yeah, it is installed on my machine. You can also install it with pip install locust. We can see that it is already installed. I'll be using locust -f and the file name loadtest.py. This would start locust on this particular port on my local machine. Let us navigate there. You can see locust is here. Here we'll provide the host address, which would be our load balancers IP and port. Also provide the protocol. And we'll be setting the number of users to 250 and the ramp up speed of requests per second to 250 as well. This would simulate a huge load on our load balancer. For this kind of a configuration of one or instances with maximum set to 3 and with each of it having only 1 GB memory, this is a significant load. So this should increase the CPU utilization, and eventually our managed instance group should increase the number of instances. Let us check that to validate our auto scaling capability. We'll set 50 and the ramp up speed to 250 as well, and we click start. We can see that the requests are scaling up at a rate of 250 and we don't see any failures now. We can also see the charts. You can see the requests per second increasing gradually. Let us get back to our balancer and our Let us get to the managed instance group. We can now see that there were only one instances initially, but now we can see that they have been scaled up to three. There are already two healthy instances. We can the managed instance group has also started creating one more instance which is being created. This is to handle the load which we have created now. Even in locust we can see that initially when we ramped up the load, the response time also ramped up, but eventually when the instances have been auto scaled, the response time also has come down. This shows that our managed instance group is able to handle uh, heavy load and auto scale on its own, and our load balancer is able to evenly distribute the load across the instances. We can see that all three instances are up, which is the maximum limit. And the console we have also an warning that this group has reached the maximum instances. Let us go into monitoring. We can see that the instances have been increased. This section in the console, it might take a little time to update, but it will eventually update to show the chart of how the instances have been increased and the CPU utilization as well. You can wait a minute or two to see the current instances and the CPU utilization in the monitoring panel. You can see that the monitoring section has eventually updated, where we can see that initially the managed instance group was with 0 instances scaled to one minimum instance when it was created. And we can also see that it has been scaled from one instance to three because of this load. We can see the load CPU utilization increase, which has caused our instances to be scaled. So now we will stop our load test. This should bring the load to these instances down, and we'll wait a minute to see how it affects our CPU utilization and the instances eventually. We can see the sharp decline in the load once we shut down the load test. And eventually this CPU utilization, the mean should go below 60%, which should automatically scale down the number of instances that we have on our managed instance group. Might take a minute, but this will eventually happen. Let us wait for it. Eventually, after some time of inactivity, we can see that the CPU utilization has gradually went down from 190% to means utilization is now 3.1%. And we can see that our managed instance group has decided that to bring down two instances and keep only the minimum instance number of instances required, which is one. This shows that our the instance group is able to auto scale and scale up and scale down the number of instances based on the load, and our load balancer is able to evenly distribute the traffic to the instances. With this, we end this lab. Stay tuned to our upcoming labs. Thank you.